The next concept we'll look at is finding the compositions of two functions. So we're given two functions, f of x equals 3x minus 2 and g of x equals 5x plus 1. So it says find the compositions f of g and g of f. So there's two ways to write finding the compositions. One is f and a little circle in between of g of x, or f of g of x written this way. Okay, so be familiar with both because in different questions, they'll have different ways to write it. So f with a little circle in between, g of x, or f and then the parentheses, g of x. So how do we find the compositions of functions? So we always work from right to left. So in this case, what we're going to do is, since the g function comes second and it's furthest right, we're going to take the g function, which in this case is 5x plus 1, and substitute it for the x in the f function. So we have 3. Now instead of x, we substitute the entire g function, the 5x plus 1, and we still have the minus 2. So all we did was take the g function and substitute it into the x in the f function. And now you simplify. So 3 times 5x is 15x, and 3 times positive 1 is 3, minus 2 gives us 15x plus 1 as our final answer. So the second composition we need to find is g of f of x, or again written a different way but meaning the same thing. So again, we work from right to left. So we take that f function, which is 3x minus 2, and replace it into the x in the g function. So we have 5, then 3x minus 2 to replace the x, and we still have, in this case, the plus 1. So again, using the distributive property, 5 times 3x is 15x. 5 times negative 2 is negative 10. And we still have the plus 1. So that gives us 15x minus 9 as our final answer. So the next, we're given again two functions. S of x equals the opposite of x plus 1. T of x equals x squared plus 1. And remember, this is a little bit different as far as the way it's written. It could be written in one of two ways. So it could have been written as S in that little circle of t of 4, means the same thing. So again, we work from right to left. So what we do in this case, instead of it being an x, it's a 4. So we're going to take the 4 and replace it into the t function. So again, right to left. So 4 goes into the t function for x, and that would give us 4 squared plus 1, which is 16 plus 1, which equals 17. Okay, so we got the answer of t of 4. Now we take the answer now and replace it into the s function for x. So that gives us the opposite of 17 in this case, plus 1, which equals negative 16. So our final answer is negative 16. So again, work from right to left. We place the 4 into the t function, get the answer, which was 17. Take the answer and replace it, in this case, into the s function. Our next example, we're doing that 2 times. So we're taking r of q of 1 first, and then we're taking Q of R of 1. So again, working from right to left. I take the 1 and replace it into the x of the Q function. So that's -2 times 1 minus 2. -2 times 1 is -2. Minus 2 is -4. So that's my answer for Q of 1. Now I take my answer and I replace it into the R function for x. So now I have 2, instead of x squared, it's going to be 4 squared. So that would be 2 times 4 squared, or 16, which gives us 32. So again, work from right to left. So the next question, it's Q of R of 1. So again, working from right to left, we take the 1, replace it into the x in the R function. So we have 2, and now we have 1 squared. Well, we know 1 squared is 1, so we have 2 times 1, which is 2. So that's our answer for R of 1. Now we take our answer and replace it into x in the Q function. So now we get -2 times 2 minus 2. So -2 times 2 is -4. Minus 2 gives us -6 for our final answer. So again, the key is to work from right to left. Our next problem, again, it says find the composition of f of g and simplify your answer as much as possible. So we're given two functions. F of x is x over x minus 1. G of x is 7 over x. And we need to simplify. So what we're going to do is take the g function, since we're moving from right to left, and substitute it in for the x in the f function. So we have two instances of x in the f function. So the 7 over x replaces the x in the numerator, and we have 7 over x minus 1. So we replace the x in the numerator and the x in the denominator. The minus 1 stays the same. Okay, so now what we have is a compound fraction. So we have a fraction within a fraction. The easiest way to simplify this, not the only way, but the easiest way is to multiply every term by the common denominator. In this case, the common denominator is x. So I'm going to multiply everything times x. So in the numerator, the x's reduce, just leaving me with 7. In the denominator, the x's reduce here and leaves me with 7. And we have minus x, or minus 1x left. So simplified, our answer would be 7 over 7 minus x. Now it says find the domain. So again, as I said in prior videos, we'll deal with finding domains more in depth later on. But remember that anytime you have a fraction, your denominator cannot be 0. So the value that makes your denominator 0 here is 7, because 7 minus 7 is 0. So we know that x cannot equal 7. So how do we write that in interval notation? So if you look at a number line, interval notation pretty much defines your answer as it would be seen on a number line. So we know it can't equal 7. So I'm going to make an X telling me it can't be 7. But it can be on any point on either side of 7. So how do we define the points on either side? So when we look at the left side of 7, this graph continues indefinitely in the negative direction. So it goes from negative infinity and stops at 7. So as we move from left to right, the point furthest left is negative infinity. And where does this particular segment end? At 7, because 7 is not included. Since we have two segments, we use the union sign. So the graph continues from 7. And where does this segment end? It continues indefinitely to the right or to infinity. As I said, we'll go more into depth with domains later on. The next problem says we have h of x equals the cube root of 3 minus 2x. Find two functions f and g such that f of g of x equals that answer. So it means, what would those two functions have been in order to give us that particular answer? So remember, we work from right to left. So the g of x would be what we plug into our function, cube root function in this case. So the g of x would be your polynomial, in this case 3 minus 2x. Now what did we do to 3 minus 2x? We took the cube root of that. So our f function would be what we did to that particular polynomial. So we took the cube root of whatever g was. So again, you're breaking this down into two separate functions. The first being the polynomial, the 3 minus 2x. And the f of x, since it's furthest left, is what we're doing to that. We're taking the cube root of whatever that polynomial would be. In a minute, we're going to be discussing inverse functions. In order for a function to have an inverse, it has to be what we call one-to-one. So we talked about the definition of function earlier. The definition of a function is where the domain value can only have a single range value or a unique range value. So we knew that a function, the x value or the domain value, could not repeat. For it to be one-to-one, the same has to be true for the range value. So let's look at an example before we get to these problems. So if I had a function 0, 1, 2, 1, 3, 5, for instance. This is a function because our domain values are not repeating. This is not one-to-one because I have a range value repeating with different domain values. For it to be one-to-one, it has to be a function It's a function because our domain values don't repeat. And it's also a one-to-one function because there's no repetition in our range values either. So how do we determine that on a graph? Instead of using a vertical line test like we did in finding whether or not a graph represents a function, we do the horizontal line test. So when we draw a horizontal line, it can only intersect the graph in one point. So anywhere I drew a horizontal line on this particular graph, notice it will only intersect. So yes, this is a one-to-one function. Let's look at this next example. In this case, when I draw the line, it only intersects the bottom point. So that's only one time. But when I go up a little bit higher, notice that it intersects more than one point. Therefore, it's not one-to-one. For this graph, when I draw a horizontal line, notice it intersects the graph in more than one place. Therefore, it is not one-to-one. Another example. Again, in this case, if I drew a line here, or if I drew a line here, it would intersect in more than one place. Therefore, it is not one-to-one. In this last example, there's no place where I could draw a horizontal line where it will intersect in more than one point. So this would be 1 to 1. Okay, so now let's look at another example. It says the one-to-one function g and h are defined as follows. G has -7, 9, -5, 4, 4, -2, 6, and 7, and h of x equals 3x minus 10. Okay, so we're going to talk about new notation. So now we're going to deal with what we call the inverse. So the inverse of a function, so if I'm talking about the inverse of g, it'll be g, the -1, and whatever the variable is. So that's the inverse of the g function. So what happens in an inverse? What does it mean to find the inverse? Essentially what's happening are that if you looked at a table of values, and this is just made up values, if the original function had values that look like this, the inverse would mean that the y value changes position with the x. So that would be, instead of 2, 3, it'd be 3, 2. The inverse of 4, 1 would be 1, 4. The inverse of 5, -3 would be -3, 5. So when you're finding the inverse, essentially what's happening, the x and y values are switching place. Okay, so now it gave us ordered pairs, or a function written as ordered pairs, and also a function written in the form of a linear function 3x minus 10. Now it's asking us to find the inverse of g of 4. So what we're going to do is, remember, x and y switch places. So when we're finding the inverse, this is no longer x, but it's y. So when I look at the g function, I'm going to look at where the y value is 4. And the y value is 4 at this particular ordered pair. So the inverse would be the x value in this case, which is -5. Okay, so now when I'm asked to find the inverse of a function, so the function's given as h of x equals 3x minus 10. Remember earlier we discussed the difference between function notation and writing it in the form of an equation. So instead of h of x or f of x or g of x, remember this took the place of the y. So this is essentially y equals 3x minus 10. So when I'm finding the inverse of a function, when I'm given a polynomial, what I'm going to do is switch the x and y, because remember, when we're finding the inverse, x and y switch places. So this becomes x equals 3y minus 10. And what I do is solve for y. So in this case, I'm going to add 10 to both sides. And then in my last step, I'm going to divide by 3. So y would equal x plus 10 over 3, or in this case, the y represents the inverse of the h function, because again, x and y switch places, and I solve for y. So this would be the x plus 10 over 3. Now we're going to go back to what we just talked about with composition. So we have h of -1 of -4. So what do? Work from right to left. So the -4 replaces the x in the inverse function. So this becomes -4 plus 10 over 3, which is 6 over 3, which equals 2. Now I take the answer that I just found, and it replaces the x in the h function, the 3x minus 10. So now I have 3 times 2 minus 10, which is 6 minus 10, which equals -4. Okay, now it says, determine whether f and g are inverses of one another. So for two functions to be inverses of one another, when we take the composition of the functions, so when we take f of g of x, if they are inverses of one another, the answer is going to be x, as well as when we take g of f of x, the answer has to be x as well in order for these functions to be inverses of one another. And that's why in this problem, you see them wanting you to do these two problems. And remember the notation. It could be written with the parentheses, or it could be written with that circle separating them. So what we have to do is find f of g of x first. So g of x is 2x, and f of x is x over 2. So when we're finding f of g of x, remember, working right to left. So I take the g function, which is 2x, and it replaces the x in the g function, in the f function, I'm sorry. So that would be 2x over 2, which equals x. So far it meets the criteria of them being inverses. Now let's find g of f of x. So again, working from right to left. I take the f function, which is x over 2, and it replaces the x in the g function. So I have 2 times x over 2. So keep in mind the 2's will reduce, and my answer also is x. So it met the criteria for the functions being inverses. So in this cases, they are inverses of one another because the answer is just x. The formula for the volume V of a cylinder with radius r and height h is as follows. V equals pi r squared h. Suppose the height of the cylinder is 2 units shorter than the radius. Rewrite V in terms of r only. It's not necessary to simplify. So all we're going to do is write the relationship. So first it says, suppose the height of the cylinder. So I'm going to write height equals 2 units shorter than the radius. So it'd be whatever the radius is minus 2. So all they want us to do in this problem is substitute the r minus 2 in for h. So now we'd have volume equals pi r squared. In place of h, we're going to write r minus 2. Now we've written volume in terms of r only. You don't see any other variable here. In the next problem, a plant is already 12 meters tall, and it will grow 10 centimeters every month. The plant's height, h in meters, after x months is given by the following function. And of course, the 12 comes from the 12 in the original problem here, and the 10 because it grows 10 centimeters every month. What is the plant's height after 40 months? Okay, so keep in mind again, make sure you're reading, and it says that x represents months. So that means the 40 is going to replace the x in the problem. So here we would have 12 plus 0.10 times 40. So we would have 12, and 0.10 times 40 is 4. So the answer would be 16. So again, pay attention to what the variable represents, and then you'll know where to plug the values into. The next problem, it says the one-to-one function h is defined below. Why do they say it's 1-to-1? Because it's asking you to find the inverse of this function. Remember, the only way a function has an inverse is if it's 1-to-1. So now we have the function h of x equals 3x minus 8 over 2x plus 5. So remember, the best thing to do is change it into the form of an equation. So instead of h of x, we're putting y in its place, and we have 3x minus 8 over 2x plus 5. Okay, so remember, when we're finding the inverse, x and y switch places. So this becomes x equals 3y minus 8 over 2y plus 5. Now we have to solve for y. So what we're going to do is clear the fraction by multiplying both sides by the common denominator. In this case, the common denominator is 2y plus 5. So on the right-hand side, the 2y plus 5 cancels out, and that just leaves me the 3y minus 8. On the left-hand side, I have x times the 2y plus 5. So what you're going to do is distribute here. So that's 2xy plus 5x equals 3y minus 8. In order to solve, you need the y's. Whatever you're solving for a variable, you want those isolated on one side. So what I'm going to do in one step is move the 3y from the right-hand side to the left-hand side by taking its opposite. So it's 2xy minus 3y. Remember, it's a positive 3y here, so when I go across the equal sign, it becomes negative. And you said, well, what happens with this 5x? Well, it doesn't have a y, so it needs to be moved to the other side also by taking its opposite. So that gives me negative 5x, because it was a positive 5x. It's going across the equal sign, it becomes negative minus 8. Now I need to separate this y and get it out so it's isolated. To do that, I factor. So I just remove the y on the outside, and that leaves me 2x minus 3. And since I'm solving for y, my last step is to divide both sides by the 2x minus 3. So my answer would be negative 5x minus 8 over 2x minus 3. The last problems we're going to be doing deals with something called the difference quotient. So the difference quotient will be given to you, and you notice, and what you can see on your screen now, f of x plus h minus f of x over h is the difference quotient. The given functions in this case would be f of x equals 2x minus 3. So what I'm going to do is find the difference quotient for the given function f of x equals 2x minus 3. Now, most students have issues with this problem because they don't follow the directions. So what I want you to do every single time you have this type of problem, it already has the f of x, which is in the numerator of your difference quotient. I want you to write down right away f of x plus h. Why do you do that? Because that's the other part you need to find to have the numerator here. So just as we did in prior problems, I'm going to evaluate f of x plus h. So I'm going to take the x plus h, and it's going to replace the x in the f function. So it becomes 2. That's x plus h minus 3. So all I've done, and this will happen in every single problem, the x plus h will replace the x in the given function. Now I'm going to multiply that out, and that gives me 2x plus 2h minus 3. Now notice, in the difference quotient, I need to evaluate f of x plus h. I just did. So I'm going to take that 2x plus 2h minus 3, and it's going to replace that f of x plus h. Minus, because it's minus in the difference quotient, f of x. F of x is always given, so there's nothing you have to do there except for write 2x minus 3 in parentheses. And that's all over h. So now I need to remove parentheses. So I have 2x plus 2h minus 3. Keep in mind that minus is going to change both values in parentheses. So this becomes negative 2x plus 3 over h. Now, any term in the numerator that doesn't have an h should cancel out. If you look, here the 2x has an opposite. This is a 2h, so it has an h, so that's not going to be eliminated right now. Next, the negative 3 doesn't have an h, so there should be a positive 3, and there is. So that cancels out. So this leaves us 2h over h, which just reduces to 2. So the answer to the difference quotient by the given function f of x equals 2x minus 3 is simply 2. So in this problem, again, we're asked to find the difference quotient. And the difference quotient will be given to you, f of x plus h minus f of x. And as I told you before, the first thing that I want you to do is write f of x plus h. You have to find that every single time you're asked to find the difference quotient. So what do we do to find f of x plus h? The x plus h replaces the x in the problem. Okay, so now we have 5 times the quantity x plus h squared minus 7. So this is another place where students get hung up. Whenever you're expanding x plus h squared, you don't just square the x. It doesn't become x squared plus h squared. You have to literally multiply the two together. So you're going to use the FOIL method. To multiply this out. So that becomes x squared plus xh plus xh plus h squared. So that becomes x squared plus 2xh plus h squared. So that's just for this part. Now we're going to have to multiply it by 5 and subtract the 7 from it. So that becomes 5x squared plus 10xh plus 5h squared minus 7. Remember, the 7's not inside the parentheses, so we don't distribute the 5 times that. Okay, so our last step, we take our answer, and it replaces the f of x plus h minus the given problem, the f of x, over h. So we have, again, this answer, which is 5x squared plus 10xh plus 5h squared minus 7 minus, and remember, in parentheses, 5x squared minus 7 all over h. So let's remove parentheses. So that gives you 5x squared plus 10xh plus 5h squared minus 7 minus 5x squared plus 7 all over h. So remember, on the right-hand side here, that minus sign is going to change both. So this changes from a 5x squared to a minus 5x squared, from a minus 7 to a plus 7. Now keep in mind again what I said, that at this next step, whatever doesn't have an h should be eliminated. So here's a 5x squared. There's a minus 5x squared. There's a 10xh, so that's not going to be eliminated because it has an h. There's a 5h squared that also, since it has an h, would not have been eliminated. But here's a negative 7 without an h, and it has a positive 7. Our last step is to reduce. So since all of these terms contain an h, I can divide an h out of each one. So this becomes just a 10x plus 5h, because in this case, I take away one h from everywhere, and this turns from two h's just to one h. So my final answer would be 10x plus 5h, and you may see it where they factor out a 5, and you have 2x plus h written this way, since 5 divides out of each one.